Good morning, everybody. Excited to be here and have an opportunity to talk about, I think, one of the most important topics in achieving our sustainability goals, which is the connection between data and achieving decarbonization. I'll start with this premise that data is fundamental to everything we need to do to address sustainability goals. It is a cross-cutting, if you will, resource for all of the types of systems and goals that we have out there. So let's talk about some of the use cases in the built environment, making that a little wider than building automation, like the built environment would include street lights, those types of things, right? But here are some use cases that rely on data, and importantly, they rely on data from multiple sources, which is really one of the fundamental points of this conversation here today. If I want to maintain optimum efficiency of building systems, I'm going to need data. I'm going to need data to do fault detection and diagnostics. I'm going to need data during the commissioning and monitoring and verification processes. Those are data-driven. If I want to integrate alternative energy resources into buildings and also integrate them into the grid, building to grid, which is an important part of the future of our grid, vehicles to grid, et cetera, I need data to do all of that. In fact, the integration of the data is more complex than the integration of the networks, if you will, to get the data, right? And then when we want to optimize the use of different energy resources, that is a data-driven process, right? I think for the past, my experience of 35 plus years, we were looking to reduce energy. We might actually want to use more energy if we can use it from an alternative energy source. So the analyses now become much more complex of why I might want to switch between different energy resources. So in order to support these and other use cases, we have to be able to use data, and it comes from diverse sources, which leads to a very big problem, right? Building systems, building automation systems with the equipment themselves produce a wealth of data. But most of the data produced by these systems has very poor, limited descriptive information about what it is, all right? You have diverse communication protocols, literally hundreds. You have diverse data formats, and you have diverse or non-existent data models about what the data means from an individual device or system. And one of the challenges has been there hasn't been a standardized approach to data modeling or semantics, right? There are numerous standard protocols, but this one models data this way, this one models it another way, this one models it another way. I have data in a database, it's modeled another way, I have CSV files. It's bigger than the communication protocols or buses out there. And one of the key points we like to make is, names can't do the job. Well, if we just standardize on a naming convention, right? Okay, well, that can't do the job, and I'll give you a quick example. My name is John Petze. What does that tell you about me? Height, weight, where I live, nothing. All of those things would be attributes of me, right? Now, my credit card company stores those attributes in one format and another format and all of those different things, right? But if we want to bring together these systems to the operation of the built environment, it really helped to have a standard data format, okay? And what we're seeing now as we do these integration projects to accomplish the goals we talked about, fault detection, commissioning, integration, they're being delayed, and there's great resistance because there's a manual, labor-intensive process to do this manually, to get Larry's data set and figure out what the heck it means, and to get your data set and your data set and to try to figure this all out manually. It's called data wrangling, data mapping. A variety of four-letter word terms are often used during the process as well. But we can't create value until we can get through this part of the process. And one of the frustrating things for owners and operators who want to get these benefits is it's invisible to them and doesn't really make any sense. Because, in our world, right, I pick up my phone and I get data. I don't think about this problem. But in the world of building systems, it's a fundamental problem, and it forms a big barrier to the efficient use of data. Can the data be used? Absolutely, but if it's at too great a cost, then we're not going to do those things to improve the performance of the built environment. So here's a kind of a graphic representation of the challenge. The building systems produce, on the left, diverse, multi-structured device data with a lot of information or literally zero information about what it means, okay? And it comes across different protocols, right? And at the end, what we would like is to have uniform, standard model data so that I could take data and understand what it means and do something useful with it. Well, that's what Project-Haystack is about. It's a standardized approach to make data from diverse systems easy to work with, interoperable, normalized, contextualized. Project-Haystack was founded in 2011. It's an open source 501c trade association. We'll talk more about that at the end, but let's talk about what it accomplishes first, okay? The concepts were modeled after work being done in the, on the web, the semantic web, et cetera, and it's built around a core concept of tags. Think of them as attributes. I can add tags to data that I get from a different system to describe what it means. Most basic would be units, right? One of the things I like to say out here is, do you know that numbers have no meaning? Larry, I'm going to give you 100 after this session. Lashes, right? Numbers have no meaning without units, and we all use units so much, sometimes we don't think about it, but numbers are meaningless, okay? Well, that's an example of an attribute, and in the Haystack methodology, it's a tag. We have the tag for units, okay? Tags work together, though. There's a library of standardized tags, so we should all use the same tags, but they work together within a larger data modeling approach so that we can describe systems, devices, interrelationships, et cetera. That's all part of what Haystack's been working on for over a decade. So we're going to transform what we call raw data, because it comes from different devices, into a uniform and self-describing format. And I like to use an analogy that we all live with every day. I think of it as a markup language for data, okay? Why can I point my browser at your website and read what you published? Did we get our engineers together last week and said, hey, we're gonna need to know the API because I wanna read what you published? And of course the answer is no. Because long ago, in the world of the information web, we agreed on an approach, a standardized approach to mark up text, pictures, all of that data. It's called HTML. Without that, we wouldn't have the easy-to-use, efficient web that we all are dependent on now, right? If you use HTML, I can read your website. We didn't have to predefine anything. I remember back in the early days when people weren't all using the standard of HTML, and you'd go to a website and you couldn't read it, right? Very early days. Well, think about Haystack doing the same thing, but for device and equipment data. Model your data with these approaches, with this methodology, and someone else is going to be able to consume it without the manual extensive effort. So there's really some core concepts to the whole idea of data semantics and what the Haystack organization has done. First, you have a vocabulary, standardized terms that you will use for all the common phenomena that you have out there or ways you want to describe things. And this is a worldwide open source organization, and birds of a feather come together who are experts in different systems and say, here are what those systems are made of. Here's the proposal for the tags we'll use. It goes to review, and then it's published, okay? But beyond the vocabulary is the taxonomy. We want to create a hierarchy, so we want to have a modeling approach so that we can create a hierarchy or a taxonomy of the different systems, right? With the end goal of achieving an ontology that shows the relationships so that we understand the relationship between a fan and an air temperature that might be on the other side of the building that is on the air being produced by that fan, the relationships, okay? And so by utilizing this approach, we can effectively create data that can be easily used. All right. So what does it enable? Why is this important to people, right? Well, in the world of building system, it allows other applications to use that data without the people who want to use it being expert in the actual system. They can get the data and say, I want to analyze high and low temperatures in office buildings. don't really know anything about chillers or boilers. That's my project. They shouldn't have to have deep domain knowledge to be able to look at temperatures, right? Or to look at what's the average energy consumption or demand peaks on hot days or whatever, right? So that's really important because it frees the data to be used to help society in general achieve sustainability and decarbonization goals without saying, oh, you want to work with automation data? Well, come back in 10 years after you know everything about automation systems and maybe you'll have a hope, right? And we like to say making applications that just work. And here's some quick examples. Digital twins. If we can read the data out of those equipment systems, you can auto-generate the digital twin, okay? All right, digital twins are great once they're done, but the work effort to get there when you're trying to bring diverse systems together is often the barrier to even considering to use a digital twin. What if I can just read that data out with all the semantics and boom, I have the digital twin, okay? Here's another example, control logic that finds the devices it's supposed to control. You might have hundreds of fan coil units in a hotel or VAV boxes. What if I have a really optimized control sequence, but I don't want to sit down and attach it or program it or link it to every one of those pieces of equipment? Well, with semantics, basically that control sequence can find all of its targets, okay? That makes it easier to apply these optimized control algorithms that might be driven by machine learning or other AI techniques, right? Hey, I got a great machine learning algorithm that'll optimize your hotel. Wow, that's really good. Yeah, it'll just take 17 weeks to apply it to 1,000 room controllers. Yeah, that won't fly financially. But what if it takes, press a button? Okay. And it also helps with a new generation of engineering tools to streamline the process of implementing all of these different systems and connecting them together. Okay. So we like to say that this is the goal of the Project-Haystack organization, is to enable a future where you can push a button and turn that device data into true intelligence and value. So now I'll just offer a little bit of background on the organization and make a claim I like to make to get everybody thinking. Do you know that the data produced by a device is now worth more than the device? And people thinking, well, wait a minute, that room controller unit, that costs $500. Run it wrong for a year. You'll spend more than $500. Well, a chiller, that's $200,000. Run it wrong for a month. You'll burn up $200,000, right? So this is why this initiative and what society needs to do with data is so important. The data is actually more valuable than the capital equipment, okay? It's the only way we're going to make the built environment smarter. It's the only way that we're going to be able to bring these systems together to get efficiency and obviously move towards sustainability, right? And that's really what this standardized approach to data modeling does. And it's at the data layer. So you could have data that's in an Excel spreadsheet, in a database, coming off of our OPC UA, coming from MQTT. This is at the data layer. There's lots of effort to standardize the protocol layer, and that's great, right? There's a great cartoon that I'm sure a lot of you have seen, right? Oh, look at all of these standard protocols, but none of them solve my problem. We need a new standard, and now we got yet another, right? Well, what we need is to have a way above that to contextualize the data independent of how it came in. So the benefits extend across the entire value chain, from the owner-operator to the facility managers, to the system integrators who are installing systems, and even the OEMs who produce equipment. And the reason we have this slide, and often do this, is to help in our educational efforts to show there are benefits to you, Mr. Owner, from specifying or requiring that the new systems installed adhere to this standard, provide the data in this standard way. Because a lot of time owners go, well, the contractor's going to charge me more if I tell him he has to contextualize all the data with Project-Haystack, right? Well, there are benefits directly to you as the owner-operator. All right, so data needs meaning to be useful. I think that's a pretty obvious thing, especially to this group here, because it supports being able to interpret the meaning of data, to be able to determine what data you need for a specific goal. Talked about identifying goals. What data do you need to evaluate those safety or those security issues, right? And this semantic tagging approach and this worldwide standards community working to solve this helps us achieve those goals. So a little bit about on the background. It's an open source, completely open source. There are no costs to use any of the work. You can go to the site and download every bit of work that's ever been produced in over a decade of the organization. It's a 501c to run the organization. Community-driven process, driven by working groups or people who get together and say, I understand electrical distribution patterns, ground source heat pumps, variable refrigeration, flow systems, et cetera. So much complexity out there, you have to have working groups who understand it. One exciting step for the organization was to get Department of Energy funding, won an award for a 3-year program that started at the beginning of 2022 to create validation tools so that people could say, can verify that their systems have been properly tagged, if you will, so that it gives people confidence. And that project is now coming up on 1.5 years of the 3-year cycle funded by Department of Energy. Growing corporate membership, we have our board members considered founding members, we have associate members, but any individual can just sign up, get an account, participate, no cost, there's no individual fees to be a part of the organization. These organizations on the right, they do it to help. They want to see this effort move forward so that we eliminate the friction and unnecessary cost in achieving these end goals and making our built environment more efficient. Lots of case studies that span from highly technical to the commentary of engineering firms and owners and operators of why this is important to them. The organization publishes a magazine twice a year with lots of examples. Reference implementations in numerous software languages, programming languages out there, all contributed by the community open source. You can find them at project-haystack.org, wealth of information. Whoops. And you, just example of the case studies. One of the things the organization does is it hosts a live event every other year. COVID caused us to move to virtual, but next year we're going back to in-person, where the whole community comes together, like we're doing here, but with a focus around data semantics and moving this all forward. And 2023 will be in Nashville. So with that, key takeaways, this is real, this is deployed, it's in tens and thousands of buildings, completely open source, zero cost to use any of the technology, including reference implementations in different software, programming languages, et cetera. And this is key. It's the methodology is extensible, right? So you can say, well, you know what? I have a building that has systems that the group hasn't standardized the tagging on. You can use that methodology and create your own vocabulary that can still be read by another application, right? You may need some final interpretation, but you can extend this to even applications that haven't been addressed by working groups, and that's key. It's also super lightweight. You can put this in temperature sensors, okay? And interestingly enough, it's human readable and machine readable. So, technicians, when they implement systems, they're often sitting on a white plastic bucket, on a keypad or keyboard trying to set stuff up, and they're thinking about the reality of the equipment in front of them. This stuff's readable by human beings, which is a very interesting thing, because it actually, that we came out of the, if you will, the implementation side, right? So it's understandable by real users and is a successful approach to solving data semantics. So with that, thanks.